Hello everyone, my name is Lakshman. Today I'm here to explain a PowerPoint presentation on the phases of a compiler, topic in the automata theory and compiler design subject. Introduction. Finite automata is a state machine that takes a string of symbols as input and changes its state accordingly. Finite automata is a recognizer for regular expressions. So basically, finite automata is a machine that accepts stream of characters or strings as inputs and converts it into a machine understandable language. When a regular expression string is fed into the finite automata, it changes its states for each letter. So basically, the string of characters can be traversed among various states, and it can be fed as the input to the data to the machine. If the input string is successfully processed, then the automata reaches its final state. It is accepted. That is, the string just fed was said to be valid token of the language in hand. Now, in this slide, let us see some of the basic symbols that we use in the finite automata concept. The mathematical model of finite automata consists of finite set of states q, the finite set of input symbols summation, and one starting state q naught, set of final states qf, and the transition function, the transition symbol. In the right side below, there is an example specified where q naught, which is in the pink color, is the starting state, and qf with the double circles in the orange state, in the orange color, is the final state. And there is a transition from q0 to qf of 0 and qf to q0 for 0. In this slide, let us see some of the basic terminologies in the finite automata using the example in the right side image. States of FA are represented by circles. State names are written inside the circles. So in this diagrammatic example, q0 and qf are the states. Start state, the state from where the automata starts, is known as a start state. Start state has an arrow pointed towards it. So in this example, Q0 is a starting state which consists of the arrow mark pointing towards it. Intermediate states. All intermediate states have at least two arrows, one pointing to another pointing out from them. So in this diagram there are no intermediate states, but basically the intermediate states are the states that exist between the starting state and the final state. Final state. If the input string is successfully passed, the automata is expected to be in this state. Final state is represented by double circles. So in this example, QF is the final state which is represented by double circles. Transition. The transition from one state to another state happens when a desired symbol in the input is found. Upon transition, automata can either move to the next state or stay in the same state. So in this example, there is a transition of 1 from Q0 to QF and transition of 0 from QF to Q0, and there exists self transition for Q0 of 0, and for QF there is a self transition of 1. In finite automata there are two types. One is deterministic finite automata and non-deterministic finite automata. Deterministic finite automata is a state where one can determine the state to which the machine will move next. It refers to deterministic finite automata which has a fixed number of states, and each input symbol uniquely determines the next state. In simple words, it accepts input if the last state is final. Backtracking can be possible in DFA. It requires more space, and DFA is a subset of NFA, and DFA is hard to construct. Non-deterministic finite automata, as the name suggests, one cannot determine the state to which the machine will move. Hence, it is referred to as non-deterministic. It refers to the non-deterministic automata. It is finite automata in which there exist many paths for specific input from the current state to the next state. NFA is easy to construct as compared to DFA. Backtracking is not always possible. It requires less space and permits empty string transition, and it also has 5 states. Now let us come to the main topic of this presentation, the phases of a compiler. So basically, in this diagram, these are the phases that are present in the compiler design. The first phase is lexical analyzer. So basically, lexical analyzer phase will accept a stream of characters as inputs, and it will group those characters into meaningful sequences called lexemes, and those lexemes will be in the form of a token. This is the first phase of the compiler. In this phase, it reads the stream of characters and groups them into meaningful sequences called lexemes. It accepts characters as input and provides the tokens as output. Now, and those tokens will be in this format, which is represented between the greater than lesser than symbol, token name, comma, attribute value. The next page is syntax analyzer. The tokens that are produced as output by the lexical analyzer will be taken as input by this phase, and it will produce a parse tree as the output. The provided input string is scanned for the validation of the structure of the standard grammar. Basically, in the second phase, it analyzes the syntactical structure and inspects if the given input is correct or not in terms of programming syntax. It accepts tokens as inputs and provides a parse tree as output. The next phase is semantic analyzer. The parse tree generated as the output by the syntax analyzer will be taken as input by the next phase, semantic analyzer, and it will check for the guidelines of the language, and will check whether the expressions are used or not. It scans whether the parse tree follows the guidelines of language. It also helps in keeping track of the identifiers and expressions used in the parse tree. The next phase is the intermediate code generation. Basically, the code is generated in such a way that the machine can understand, and it can be understood by the humans also. Intermediate code is generated between the high level language and machine level language. The intermediate code should be generated in such a way that you can easily translate it into the target machine code. The next phase is the code optimization. So, as the name suggests, basically we must optimize the code in such a way that it runs fast and it occupies less space in the memory, and it also consists of less number of code lines. It is used to improve the intermediate code so that the output of the program could run faster and takes less space. It removes the unnecessary lines of code and arranges the sequence of statements in order to speed up the program execution. The last phase is the target code generation. Code generation is in the final stage of compilation process. It takes the optimized intermediate code as input and maps it to target machine language. So code generator translates the intermediate code into the machine code of a specified computer. So that's the explanation about the phases of the compiler. Let us see the applications of finite automata. Finite automata has various applications in computer science, which include lexical analysis, parsing, and pattern matching, and it is also used to create the compilers. Finite automata is used in networking protocols to detect errors and ensure that the data transfer between the devices is reliable or not. Finite automata are used in digital circuit. They can be used to design the logical gates. Finite automata is highly useful to design the spell checkers. So this is the end of the presentation, guys. Hope you liked my explanation about the phases of the compiler design and basic terminologies used in the finite automata. Let us meet in the next presentation. Thank you.